So I'm going to give a little talk about documenting and refactoring Python code. Originally, this was just going to be a documentation talk, but quickly I realized, I think we all kind of know, that when you refactor code, you kind of self-document it anyway. The idea is to improve your code, and to some extent, code should be it should be readable and self-documenting. So we're going to review all that today. So it's me. I'm the code boss on Twitter, Reddit, Instagram, anything. I work at a company called Clevyr. Got the Clevyr Labs shirts here. We're a consulting development shop up just about a mile north of here. We work with all kinds of technology. We build applications, web apps, virtual reality, augmented reality stuff. Two of my coworkers, Megan and Jacob, are back there. But we do all kinds of fun stuff. And we also are Clevyr Labs, which is kind of our VR, AR hub of stuff. Two companies under the same roof. If you have any interest in what we do, feel free to talk to me afterwards. On top of that, I'm also a board member of Techlahoma, so if you have any questions or complaints about how we do things at all or just want to know anything, feel free to ask me. Kimberly Collins is also a board member, so you can ask her as well. And if you've been to any of the meetups we've been to lately, you might have noticed that last month we did a big membership drive to try to get monthly donations. I'm not going to do the whole pitch for that, but I do want to encourage you to, if you've seen the pitch before or haven't, if you want to help sustain what Techlahoma does, none of the board members are paid for, everything's volunteer. Literally, like, all of our money goes to the food, like the food you're eating right now. So if you want to help sustain us, we would love to encourage you to do a monthly donation. It's, you can go as low as $8 a month, and that helps us immensely. So we've gotten, at other meetups, C# Ruby, we've gotten some members. So we'd love it if you wanted to consider supporting us. So that's just techlahoma.org/donate. Now let's get on to the talk. So this kind of started with, I think it was last year, or maybe even the year before, I started this thing, or wanted to do this thing called a year of documentation. Like, it was going to be the New Year's resolution that I focused on for coding. I'd learned a lot of things, and I knew there were some areas where I always wanted to say, yeah, I should do that, but I really don't, and documentation is one of them. That goes into creating READMEs, documenting your code, anything that can make the next developer much more easily use my code is a benefit. So I kind of say that every year is my year of documentation because I just want to get better at it every year. But that's kind of the idea behind this talk, is that I think it's an important thing that a lot of developers do as well, but maybe some of us may not do as much as we should. So today we're going to cover refactoring and documenting code, specifically with Python. We're going to talk about refactoring first, and we're going to do a demo. There's not going to be any live coding, but there will be code nonetheless. So I've got first of all, is this zoomed in enough? Can everybody see this? Okay, if you can't, feel free to raise your hand. I've got 9 example files here. They're all short, and they all build on the previous file. And we're just going to basically take a small bit of code, which is this thing right here, and I'm going to shrink that side. We're going to take this, and we're just going to refactor it, and then we're going to document it. So this is a function called doTheThing. It does some stuff here. Looks like it sums up a list comprehension here. It has some sort of checks to make sure it's still an integer and a float, and that the number is positive, and then we just multiply it by 1.08 for whatever reason, and then we return it. And we call it just by saying doTheThing, and we pass in a list of random stuff. So when we do that, let me hop into the code directory, and that's not how you spell Python. We get 19.3212. That's fine. It's all great. We're just going to make this thing much better because this is not a great piece of code right here. It's short. It's like 5 lines of code, but I would argue this is not readable. You have no idea what's going on. A lot of us here are Pythonistas, so we can probably read this, and this is a pretty simple example, but the idea is if you're dealing with a code base that looks like this, that's not a great thing. It's a code smell, if you will, where it still works, but it's not great. So let's see what we can do to make it better, first of all. So the first thing that we want to do, and this is in the refactoring phase, we can just rename the functions and maybe rename some variables, a few of them, just to make it much more easy to kind of understand what's going on. So we just rename this function to, instead of doTheThings, it's generate total price. It's a little bit more, you kind of get an idea of what's going on here, and instead of just passing in x, we're passing in amounts. So otherwise, it's still the exact same thing. We did sub out the list comprehension variable for amount, so instead of just I, and when we call it, we're saying generate total price. So it's a little bit more indicative of what's going on here. So name your functions appropriately, name your variables appropriately. We can still go a little bit farther with the variable naming, but The next thing that I would want to do is this line here is just a behemoth. Like this is, a beast. It's almost that marker you're seeing on the far right side. That's the 80-character column line. That's still pretty short, but we can make this better. So let's do that with the next example. So we're getting into kind of code styling here. Maybe you agree with this, maybe you don't, but to me this is much easier to read, where I don't have to, if I can just scroll vertically versus scroll horizontally, that's easier for my eyes to read. So we didn't change anything other than just kind of using white space appropriately for this line here. So we took the one line, changed it into 5 lines. That's one thing you'll find with refactoring, is it does not always lead to lesser code, and that's an okay thing. I've kind of found that I would love to strip away a ton of code, code lines, but if I can make my code longer and significantly more readable, that's a benefit, because I need, other people are going to be using my code. So that's all we did here. So this line is much more easier to read now. Still the same list comprehension. We're still doing the same thing. The next thing I'd want to address is this kind of magic number right here, this 1.08. What does that even mean? You might assume that you kind of know what it means, but that's never a good thing. I, as a developer, should never make you, another developer, assume what anything is. And kind of the same thing with this list here. What does this list represent? They're magic, a magic list and a magic number. So what I would want to do is extract that out to a variable so you can actually kind of get an idea of what's going on. So we now know that that number represents a tax rate of some sort. So we're going to actually use that here. So we're saying, okay, we've got the sum here, we're multiplying it by a tax rate. And we did the same thing down here. We extracted the list to a variable called all amounts. It's still not super clear, but at least you kind of know that it's an amount of something. It's not just, it's kind of not just a random number. And the A there is just supposed to be, bad user input, which we just kind of hard-coded for now. That's kind of why we have the check in here, to make sure that if we're only adding things that are floats and only things that are greater than 0. So the negative 100 and the A in this list is getting completely ignored. Again, just kind of assuming bad user input. The next thing I'm going to do is we can extract out even more variables from this, because we're getting a little bit more clear of what's going on here, but this is still kind of a big thing going on here. We're returning the summation of this list comprehension and then multiplying it by the tax rate all in that return line. That's still a lot. We can make that a little bit better too. So let's do that. So we just extracted out the whole summation of the list comprehension into another variable. We didn't have to do that, but it kind of makes things a little more readable here. So we extracted that to a subtotal, created another variable called grand total here, which is just subtotal times tax rate, and we're just returning the grand total. So this is kind of the idea of self-documenting code, and this is all just going through refactoring. We're not explicitly documenting anything, but you have a much better idea of what's happening here than you did before. And we really haven't done anything down here other than we added the generate total price. We equated that to a variable here, and we're just printing that out. Again, we're kind of getting diminishing returns with this down here, but that's fine. It's as long as I can make it more readable for the next developer, that's the important thing. And the only other thing we're going to do with refactoring is it's kind of a code smell to have a lot of logic and the if name equals main conditional. So we're just going to extract that out to a function, and there we go. So you can kind of see we didn't add in a ton there. So we just extracted that to a function, and we're just going to call main right now. And we're done with refactoring for now. Let's hop back to the slide. So kind of to summarize what we did, just use variables, use white space appropriately. And this is an opinionated thing, the shorter lines bit. I don't like having extremely long lines. Just try to keep it short, kind of have logical breaks where they make sense. And then keep things readable is the most important thing in my opinion. As you kind of develop more, I've realized that it's not about how clean I can make it, it's about how good I can make it for the next developer to use this code. I've worked on code bases that are 20 years old, and I have no doubt that that's going to be me one day, that my code will be used 20 years down the road as well. And then one big thing that we just kind of touched on is refactoring doesn't always lead to shorter code, and that's an okay thing. Oftentimes it does, but it doesn't always, and that's completely okay. So hop into the next thing, the kind of core of this talk, documentation. How can we make our code better documented? And we kind of have started on that a little bit. We're going to hop back to the demo. This is much more easier to read than what it was before. It's longer, but it's much more easier to go through. So, and just to prove we're kind of at the same point, if I just print on example 6, we still get the same number. Now, what I'm going to talk about next is this thing called pydoc. If I do a pydoc example, let's just do pydocsys, something that exists. This is Python's documentation system. Very nicely documented tool, which is an internal tool here. And by default, we can do that with our files as well, example 6, but it's not nearly as awesome. We have a name, example 6. You can see the file, which is fine, and then we get our functions, which are generate total price, amounts, and main. It's helpful, but it's not that helpful. We can make this better, and we can do that using just docstrings in Python. So I'm going to close out of that. I'm going to hop back to here. And we'll go to the next example. And I'm gonna full screen this pane just because it's a little bit, this is the important pane. So we're in the next example. All we've done is just add some docstrings. We added a docstring to the beginning up here, Python's 3 quotation mark docstring. Added it. So this will actually tell us what this file is for, or what this module is for. We can put a docstring on the function to tell us what the function does, and then we do that down here on the main function as well. And that's it. That's all we've done. But just by adding those 3 things, if we run this pydoc again, we get a lot more information about what we're doing. It's not perfect, but it's more information. So on our name, we say this, it automatically will pull in the docstring. This is a demo on how to document and refactor Python code. And the function, we get blurbs of these, generates the total price for the passed in amounts, and the main function do not import. That's pretty important for that main function because by default, every function is allowed to be imported in a Python module. So we can kind of explicitly say, don't use this thing if we don't need it to be used. Going on further, we can actually improve this docstring right here because not only are we getting a parameter passed in, we're actually returning a value as well, and we're not being clear about that. So taking that to the next level, we can add in, these are just kind of conventions for how Python docstrings work. We can explicitly say we're passing in a parameter, which is amounts, and we give a little description. That's the list of amounts, and we're returning the grand total. And there's other options you can pass in here. These are just kind of by convention. And now if we run this module, we get out that information as well. Now by default, pydoc will print out the whole pydoc string, so you can put whatever you want in there. It doesn't have to match this format, but this is the convention, and I would argue that you should always follow this convention. It's just, other developers are going to be looking for it. And then the only other thing about documentation that I'm going to touch on is docstrings won't get you all the way there. They're incredibly helpful, and I think it should be something you include on every function. It's there. But even within a function, you're going to get some complex logic. And I would argue we don't have anything complex here, but that subtotal list comprehension is a little bit, not messy, but there's a lot going on, especially if someone were not a master of Python looking at it. So what we can do is we can just add normal comments, which are probably the things that everyone knows about. We just kind of, if we go up here, we just have a normal comment, only sum the values that are numbers and positive. Just something simple to kind of to help the developer understand what's going on here. And even online, this line right here, this is obviously pretty clear to understand what's going on here, but we're just explicitly saying we're going to build the grand total here. And just to prove that everything still works just the way it did, we're going to just run 9.py. We get the exact same number. So we did not actually change any functionality. We increased a lot of lines of code. We went from 5 to 34. Granted, we're using white space and everything, but we're at a much more readable solution. We're at a much more documented solution. Every developer is going to be different, but I would argue this is, being more verbose in a situation like this, I think is very important and very helpful. So to kind of summarize there, self-documented code is, I think, a first thing that you should do when documenting your code. That's an incredibly helpful thing, and it usually makes your code much better. Use docstrings in Python, and then just general comments as needed. That's all I've got. If you want to know more about the company that I work for, Clevyr.com and ClevyRLabs.com. And that's me. I'm Aaron Krauss. I'm the code boss everywhere, and my personal website with a blog is thesociety.org. Any questions? All right. Thanks a bunch, everyone.